Today we're going to look at lesson 7-6, which is all about exponential functions. So our objective is we are going to graph an exponential function. So let's talk about what an exponential function is. It says that it's a function of the form y equals a times b raised to the power of x. This is where a cannot equal 0, b has to be greater than 1, or b cannot equal 1, and x is a real number. All right, so a times b to the power of x. So b is your base, x is your exponent. We're never going to multiply by 0. Okay, as you can see from this picture, an exponential function is going to have a curve to it. So it's either going to start off really, really big and then start getting super, super small, or it's the opposite. It's going to start super small and then start getting big really fast. Okay, so those two models here we've got in black. This graph is an exponential decay because it's starting off really, really big and it's getting smaller and smaller and smaller. So to get smaller means we are decaying. The red graph is an exponential growth. So you start really small and you start getting big really, really quickly. Well, that makes sense that it's growth. It's starting to get bigger. So let's take a look at this example. It says an investment of $8,000 in a certain certificate of deposit, which is known as a CD, doubles in value every year. The function that models the growth of this investment is f of x equals 8,000 times 2 to the power of x, where x is the number of years. If the investor does not withdraw any money from this CD, how much money will be available for withdrawal after 4 years? So basically what this problem is talking about is they're giving us this exponent of x, and they're telling x is representing the number of years. Notice that the problem itself in the very last part of this last sentence says how much money will be available for withdrawal after 4 years. So the fact that they're giving us the amount of years and x represents the amount of years, well, all we're going to have to do is we are going to substitute 4 in to this function. So I'm going to then say that it's f of 4 because I'm really going to replace x with the number 4. So then that equals 8,000 times now 2 to the 4th power. And this is where you get to use a calculator. So if you have your calculator on your phone, you can feel free to use that. Remember, we do technically have a calculator if you clicked on the calculator from my classroom Bitmoji. So if I use this calculator, I'm going to do 8,000 times, and then I'm going to do 2, and then I'm going to come over here to the left where it says a to the power of b. I'm going to click that, and now that allows me to do an exponent. The exponent is 4. And so then notice that my answer is right here. It's 128,000. So that's going to be then how much money we're going to be able to withdraw after 4 years. So we got $128,000. And that would be my answer. Okay, so there are going to be times where I might give you an equation and I am telling you and defining what it is, and you just have to know, okay, I'm going to plug that number in and I can just calculate using a calculator. Okay, so same idea right here, it's just not word problems. So it says to evaluate each function for the given value. So f of x equals negative 0.2 times 5 to the power of x, and x is 10. So we are finding the function at 10. So we are going to be plugging in 10 in for our exponent. Okay, and then once again, you can use your phone calculator. I'm going to go back to the calculator on our page here. So I'm going to go ahead and I'm going to clear all. and I'm going to try this problem again. So I'm going to have a negative. So let's figure out how to do negatives here. I guess I might just hit the subtraction sign. 0.25. I don't think that's right. Let's look. So, nope. Where is the negative sign? Oh. All right. Oops, it's not 0.25, it's 0.2. And then that's being multiplied by 5. And then once again, we've got our exponent here, so the 10th power. And so by doing that, so yeah, anytime there's a negative in this case, you're just going to have to hit the subtraction sign, it looks like. Okay, but this a negative 0.2 times 5 to the 10th power looks like it's giving us this negative 1,953,125. So that would be my answer for this first problem right here. So we've got negative 1,953,125. Okay, so then same idea for this next one. We've got g of t equals 3 times 0.8 to the power of t, and they want us to know when t equals negative 1. So that means I'm plugging negative 1 in for t. So 3 times 0.8 to the negative first power. So once again, I'm going to go ahead and I'm going to go to my calculator, and I'm going to do that. So I'm going to clear this. We've got 3 times 0.8. Once again, I'm hitting this a to the b power to get to the exponent, and I want a negative 1. And as you can see, we've got 3.75. Okay, so it's okay that it's a decimal here. Notice that this right here, it's actually letting us convert to a fraction. So it could be a fraction, but I'm going to leave it as a decimal. So 3.75 would be my answer there. All right, so anytime I'm giving you an equation, you're substituting in the value in for the exponent and calculating that out. So that's going to be the concept then when we have to start graphing. So if it's asking for us to graph the function y equals 3 to the power of x, notice that in this table, we are going to pick some values for x that we will plug in as an exponent. So the easiest numbers to pick are going to be numbers that are surrounding 0. Okay, so it looks like we've got 4 spots. So I'm going to go a little bit past 0 on the left. I want 0, and then I'm going to do a couple of numbers on the right of 0. Okay, so these are going to be the numbers that are going to go in as our exponents. So we're going to have y equals 3 to the negative first power, and we'll calculate that out. We're going to have y equals 3 to the power of 0. We're going to have y equals 3 to the first power, and we'll have y equals 3 squared. Okay, once again, you can use your calculator for this. So if we see that we have 3 to the negative first power, I'm going to do it right now without a calculator, but you can go ahead and you can use the calculator right away. But because it's a negative exponent, remember, I can think of it as like over 1. I'm going to move that whole term down to the bottom, which will then change my exponent positive. So it's really 1 over 3 to the first power, or 1 over 3. So as a decimal, if you were seeing this in your calculator, you see 0.3 repeating. So that means that that's my value for y. So I'll have negative 1, and then I'll have 0.3333. So I just put that little bar above it to show that it's repeating. Okay, so that means that that's an ordered pair that I get to plot. So notice that x is always first. Well, here's my x-axis. The y-axis is the vertical line. So I'm going over to negative 1. And then because 0.3 repeating is a decimal, it's smaller than 1 because it's 0 point, but it's a positive number. So it's going to fall in between 0 and 1. So we are going to be plotting points that are not necessarily super, super nice points. We're going to have to kind of estimate. So notice how I went just a little bit above 0, but it has to be smaller than 1 because 0.3 is in between 0 and 1. If I look at 3 to the power of 0, you can use a calculator, but hopefully you recognize that anything to the power of 0 is just the number 1. So we've got the ordered pair 0, 1. So 0 means I don't move left or right, but 1 means that I'm on the y-axis. If I have 3 to the first power, well, that means that we'll just have 3. So we have an ordered pair of 1, 3. So I go over 1 and up 3, and I plot my point. And then in the last one, we've got 3 squared. Well, remember 3 squared is 3 times 3. 3 times 3 is 9. So we've got the ordered pair 2, 9. So I go over 2 and up 9. Notice how there's starting to be a curve. Had I gone to more negative numbers, I would have more decimals that are getting smaller and smaller and smaller, but never actually hitting 0. So this is where it's going to be important that we actually are never going to touch that x-axis here. We're getting super, super, super close to it, but it will never touch it. So I need to be slightly above it. I got arrows on both sides. There's a curve to it. This is not a straight line. This is my graph. Let's take a look at another example. We're going to graph the function y equals 1/2 to the power of x. So once again, we want to pick some numbers that are surrounding 0 to be created as the numbers that are going to go in as exponents. Okay, this time I'll pick a couple more negative numbers, but I've got 0, and I'm picking numbers surrounding 0. So I'm going to do -2, -1, 0, and 1. So those are going to be my exponents. So we'll have -1/2 in parentheses raised to the -2nd power. In parentheses, we'll have 1/2 raised to the -1st power. We'll then have 1/2 in parentheses raised to the 0 power. And we'll have 1/2 that's raised to the 1st power. All right, once again, you can go ahead and use a calculator. So I'll show you how to do this with the calculator. Okay, notice that we are going to want to keep that 1/2 in parentheses. So over here on the left, I see parenthesis. Then I can do a fraction, and I can do 1/2. Then I'm going to click outside of the parenthesis. I guess I have to close that parenthesis, so I have to put it there. And then I'm going to go back to this button where I can then have an exponent, and I'm raising that to the -2nd power. And notice that when I do that, I'm getting an answer of 4. So 1/2 raised to the -2nd power is going to give us the number 4. So my ordered pair is -2, 4. So once again, x goes first, y goes second. I'm moving 2 to the left and up 4, plotting my point. If we have 1/2 raised to the -1st power, same idea. You'd go to the calculator, type the parenthesis, do the fraction, and then close the parenthesis and raise it to the -1st. You'll see that that ends up being the number 2. So we get -1, 2. So 1 to the left, up 2, plot my point. Remember, anything to the power of 0 is just going to be 1. So we've got the ordered pair 0, 1. So 0 means I do not move left or right, but 1 means we move up 1. If we have 1/2 to the first power, that means it's 1/2. So remember, if you have 1/2, we can convert it into a decimal to make it a little bit nicer if you want. Okay, so if I clear all, if I have the fraction 1/2, notice how it's giving it to me then also as a decimal, it's 0.5. Okay, hopefully you'd be able to see 1/2 very easily on a graph. It's going to be halfway between two numbers. Okay, but the ordered pair is 1 and then 1/2. So I go over 1, and then in between 0 and 1, which is halfway there, I can plot my point. So notice that there is a curve. I'm going to connect these points, and it's curving down. And once again, we're going to be getting closer and closer and closer to the x-axis, but not actually touching or crossing. And then this would be my graph. Let's do one more example. We're going to graph the function y equals -2 times 1/2 to the power of x. Okay, once again, we want to pick some numbers that are going to go in as our exponents. We want to pick numbers that are surrounding 0. So I'm going to pick a couple of negative numbers again. I'll pick 0 and I'll pick then +1. So we will have y equals -2, then in parentheses 1/2 to the -2nd power. We'll have y equals -2 and then 1/2 raised to the -1st power. We'll have y equals -2 and then 1/2 raised to the 0 power, and y equals -2 and then 1/2 raised to the 1st power. All right, once again, I'm going to go ahead, I'm going to use my calculator and show you how we would type this in. So I'm going to clear this. We had -2, so I'll do -2. Then I'll do parentheses. I'll do my fraction, and I want 1/2. I'll close the parentheses. Oops, sorry, I have to go back. So I think I arrowed that. Nope. Okay, so I'd hit that little button right there to go back. I want to move outside of that fraction, close the parenthesis, and then use that a to the power of b button to get an exponent, and then we want -2. So notice that it's calculating, and it looks like we're getting a number of -8. So I plugged in -2 for x, and this then equaled -8. So we've got the ordered pair, -2, -8. So on my x-axis, I go over to -2. On my y-axis, I go down to -8, and I plot my point. In the next one, let's go ahead and use our calculator again. So we will have, and what I'm going to do is I can use the exact same thing, but I'm just going back up here, and I can backspace, and I can then type in -1 instead, and so I don't have to retype all of that stuff because it's essentially the same. I just want to change the exponent. And notice that it's giving us now a -4. So plugging all of that in, we ended up with a -4. So our ordered pair would be -1, -4. So I go 1 over to the left and then 4 down, plot my point. In the next one, once again, you can go back to the calculator, you could backspace that exponent, you can type in 0. In this case, because we have something raised to the power of 0, remember that's going to turn into the number 1. However, there's still that -2 outside, so it really turns into -2 times 1, which would give us -2. So we have the ordered pair 0, -2. So 0 means I don't move left or right, -2 means I move down 2. Okay, last number here, we have -2 times 1/2 to the 1st power. Once again, you can use your calculator, but if anything's raised to the 1st power, then it's just being multiplied by itself one time, so I don't really need that exponent. -2 times 1/2 is really -1. So my ordered pair is 1, -1. So I move 1 to the right and 1 down. And notice that this time, when I connect my points, there's a curve. And then we are going to be getting, once again, closer and closer and closer to the x-axis, but we're not actually going to touch it or cross it. And these are some exponential graphs.